Hi, Scott Jennings. Today we're discussing an engineering failure, but not so much an engineering failure, I would argue more of a communication failure. So back in 1981 at the Hyatt Regency, near its grand opening, they opened the hotel and had an event there with several hundred people, and these walkways that were recently built, brand new, collapsed. And the reason was an engineering reason. A washer got overloaded. The actual walkways were suspended by the ceiling. The fourth floor and the second floor walkways were suspended by the ceiling above. And during a party, the walkways just collapsed, and 114 people died, and a couple hundred people were really badly injured. It's in this book by Philip Wern. It's written about really all over the country, but we're going to study this book right here and take a look at some of the drawings in here and why it failed. And this is meant to be a lesson in communication failure as well as engineering failure, but even if you're not an engineer, the concept is pretty simple to understand, and that's what makes it so heartbreaking, is someone along the way should have caught it. This is a very interesting book called Collapse, When Buildings Fall Down by Philip Wern. Anyway, let's take a look at this. The Hyatt Regency is in here. Let's take a peek. So chapter 4 here on page 79 talks about the Hyatt Regency collapse. It was very traumatic, and the failure was an engineering failure, but really the failure was a management failure, a communication failure, which is very common. So you can go through here and read about it. It happened in Kansas City at the Hyatt Regency. And so you see here it says that it was on July 17th, 1981. And here's a schematic of what the actual building looked like. It's got these two levels on the right-hand side suspended by these rods. So this is a walkway, and then a walkway right below it, and then a walkway across here. This is all out in the front lobby, I believe. But this fourth floor walkway and the second floor walkway were both suspended by rods. Here's a pictorial of what was going on that night, and you see over here on the right-hand side here those two suspended walkways with a whole bunch of people dancing down below. So unfortunately, 114 people died and 200 more were injured here. Some were maimed for life. And you see here the federal government labeled this disaster the most devastating structural collapse to ever take place in the U.S. as of 1981. This is a picture of the rod that failed. The box beam, the small little steel box beam pulled through this, and this washer was not adequate to suspend the load. But here comes the engineering failure. So here's the engineering failure. So here's the platform over here. This is how it was originally designed. It was one long rod going from ceiling all the way through the fourth level and down through the second level. And what was supposed to happen, as you see here on the left-hand side by my pencil, is this first platform here, all the people were supposed to be up here walking around, and then all the load of that walkway was going to transfer into this one washer right here. So this one washer right here was going to take the load of that entire walkway. But for constructability reasons, this rod, which went all the way from the ceiling all the way down through the fourth floor and through the second floor, was just too long, and you couldn't build the walkways. You couldn't build the walkway on the ground and just push it all the way up on this rod the way it was designed. So they made a design change in the field where they would break up the rod just for constructability reasons. So they took the rod like this, and they took the rod from the ceiling all the way down here, and they put a little washer below this little box beam. And then they ended up continuing the rod here by starting the washer here and then going down to pick up the second floor. So this is the fourth floor, and what's down below it is the second floor. But if you look at, whether you're an engineer, it'll be easier to understand. If you're not an engineer, it's still not that difficult to understand. But look what's happening here on the right-hand side with all these people standing here. This connection right here is taking the load from the people. The people are, all being held here by this rod here. And then all the people down below, this rod right here, all the people down below on the second floor, all that weight is being transferred on this washer, which in turn is pushing its load over to here. So instead of over here on the left-hand side, where just this fourth floor weight was put here on this washer, because all the rest of the weight is down there on the other washer, right? Now we have, because of the new rod configuration, all the load from the second floor below comes up to this rod, and then lands here on the top of the beam, and then the bottom of the beam has to pick up everything from the second floor and everything from all the people here on the fourth floor. And so what you see happen down here below was that it just pulled out. This rod was fine. This rod pulled right through as the fourth floor, fell through. This beam just gave way, and the second floor and the fourth floor collapsed. This is a structural engineering 101 type load transfer, which hopefully is understood by you if you're not of an engineering background. Over here on the left, you see that the reason that I just mentioned, the design had been changed, and it was pretty obvious why. The first design as submitted on the plans was simply impossible to construct. So there we go, the importance of a constructability review and why you need to talk to contractors through the process. The effect of the design change was to double the load on the connections on the fourth floor walkway. That's what I just explained. Instead of having just the fourth floor loading that washer, the fourth and the second floor were loading that washer. And as you saw over here, it just pulled through. Right here, it just pulled through. If you look at the photos, which are out online, it just pulled through there and a lot of people died. When you go on here, here's an actual picture of the aftermath, just a terrible accident. This I thought was very, very important. I'm just going to read it. This was a very simple failure. There was no sophistication here. It didn't require a brilliant engineering mind. It was just obvious from day one. There were a lot of accidents on this job, which was a separate subject if you read through this, but this was just a basic engineering failure that could have been seen by even the most junior of engineers. The failure of the skywalks was ultimately a failure of the people involved in the design, construction, and inspection system who had allowed it to happen. A failure of the people. Communication, communication, communication. They go on and talk about further investigation and three main reasons. This number 2 I underlined. Reason number 2, chaotic lines of communication and chains of responsibility between designers, architects, and constructors had been the norm. So here was a job which was ill with communication. The engineering was easy, but just people weren't talking enough, and I don't know. Maybe it was on a fast-track schedule. I have no idea. I can't even say. But this was just a communication breakdown by people.